In this lesson, we're going to discuss atoms and the formation of ions. Before we go too much further, though, let's review the classification of matter. The simplest form of matter is an element, and the smallest particle of an element is an atom. An ion is a charged atom, and a compound is formed when atoms or ions chemically combine. In grade 10, we're going to discuss how these atoms or ions chemically combine and produce the two different categories of compounds. So we have ionic compounds and covalent compounds. So ionic compounds are formed from ions, and molecular compounds are formed when atoms combine to form molecules. Ions and atoms of the same element have completely different properties such as size and color. For example, the sodium atom is larger than the sodium plus ion. We also say that the sodium atom reacts very vigorously with water, whereas the sodium ion doesn't. We also had another example last year when we discussed and looked at what happens when you put aluminum foil in copper 2 chloride. In that experiment, we created elemental copper through that reaction, and we clearly showed, as in the pictures below, that copper atoms are quite different from copper 2 ions. So let's talk about how ions form. Some elements like to combine or bond to form compounds. For an element, the tendency to bond or form an ion is determined by the number of electrons in its outermost shell. We call that outer shell the valence shell. And the electrons that shell holds are called the valence electrons. We use Bohr diagrams to focus on the electron structure in the first 20 atoms. And that's what we'll talk about here in Science 10, being familiar with the first 20 atoms, what their atoms might look like, and how this influences their bonding with other elements is going to be very important for us. One theory states that atoms tend to acquire the same number of valence electrons as their nearest noble gas. Noble gases have complete valence shells. So in this example, we have neon below. Neon will not readily react with any other atom because it has a full outer shell. Fluorine, to its immediate left on the periodic table, has 9 protons and 9 electrons. It's going to want to gain that 1 electron, although 1 is perhaps a bad word, to become like neon. Whereas sodium on the right has 1 extra electron, and it will very, very easily lose that electron. This theory does explain why the halogens like fluorine and the alkali metals like sodium are very, very reactive. It's very easy for them, in the case of fluorine, to pull off an extra electron from another atom, and sodium, like the other alkali metals, very readily will lose that extra electron that they have. Bohr diagrams can be used to represent the formation of ions. Remember, when ions are formed because elements other than noble gases tend to gain or lose electrons so that they can look like the nearest noble gas. So we can use brackets to represent an ion, and what we need to understand is how many electrons an atom may gain or lose to look like its nearest noble gas. So in this case, on the left-hand side, we have the fluorine ion. Fluorine has an atomic number of 9, which means it has 9 protons. An atom would have 9 electrons, but an ion is formed when a fluorine atom gains that 1 extra electron to be like neon. Sodium on the right would lose that extra electron in its outer shell, giving it 11 protons and 10 electrons, and that helps to explain why sodium has a positive 1 charge. So when atoms gain or lose electrons, the atoms become negatively or positively charged ions. It's important to remember that only the valence electrons are transferred between atoms. So here's an example of how electrons are transferred. In this example, we have sodium and chlorine atoms. Both of them have incomplete valence shells. Sodium will readily give up its extra electron to a chlorine atom, and the result is that we have 2 oppositely charged ions, both with complete valence shells. And the 2 ions are now held together by electrical attraction, and we'll talk more about that later.